So that's why I ask you at the very beginning to ask any questions if you have during my speech, and please don't hesitate to ask me to repeat some things if I didn't explain them clear enough. Okay, so mathematical programming. That's the thing that I'm using every day in my work, and my work is about forestry. So mathematical programming is not about math only. Everybody can use mathematical programs. Lots of sciences do that, and even medical students, I think, sometimes do it. So, and I think mathematical programs can be applied in real life very easily, because very often we have a problem when we have some resource. It can be time, it can be money, it can be some raw material that we want to use to produce something. Like we want to use our time to go watch a movie, go for a walk, or to work. We can similarly use money for different things, but what is the best way to use them? Like, we don't want to miss any opportunities. We want to choose the best way to use the money and our time. So that's the problem. And the easy solution would be to just enumerate all the possible ways to use the resource, right? What if we have a million of ways to use that resource? How easy would it be to find the best use, to manually check each of these? And I don't think it will be possible. So that's where mathematical programming comes into the stage. So when I give presentations, what I usually say about mathematical programs is that mathematical program is a description of a real-world process using math. And here in math portion, we understand everything. Variables, equations, constraints, and stuff that you probably studied in your high school, but forgot about it. So I'm going to explain the mathematical program on an example. I'm going to use a classical example of building a diet. So in this example, what we have? So we want to eat healthy, right? And I think that the healthy level of calorie intake is about 2,000 calories per day. I think that's right. We also know that we have lots and lots of available products, right? And we know everything about them. Using internet, we can find prices, we can find how many calories are in tiny little piece of each product and all the other nutrients, right? Also, we know how much of each nutrient we want to take. Like, we know how much fat we want to eat, or I mean, it depends on the person. Maybe somebody wants to only fat, no other things, only fat, or only sugar. I guess every kid would love that diet. So, but we know about that. At least we can guess. What also we want is that we don't want to spend a fortune on a diet, right? So we want to minimize the cost. So that's what we know. That's what we will use in the program. So for the beginning, let's assume that we have only 3 products. It will be milk, meat, and bread. Just random products. But for a real example, you can use every product. Everything you have in the fridge and cupboard and in the store. You can plug in this in the mathematical program and it will still work. So, but the output, the solution that we want to see is how much of each of this we will eat per day to still meet all of these goals, right? Okay, let's start then. So at the beginning, we don't know how much of this we will eat, right? So this is our unknowns. Then in this is unknowns, then they are unknowns. They're x's. Also, as I said, we know everything about this product. So we know that, oh, and also, just a little note, the units. Milk is in cups, meat is in ounces, and bread is in slices. Also, using internet, it's not a big deal to find that there will be how much? 86 calories in a cup of milk, fat-free. There will be 80 calories in an ounce of meat, and there will be 280 calories in a slice of bread. So what we do is, we know 86 calories per cup, multiplied by x1 cups per day. So this will be the calories from milk that we will get in one day. Same we do with meat. And bread. Bread is the best. Okay, and we know that this should be equal to 2,000.
Nice.
That's done. We can do exact same thing with our nutrients. So again, it's not terribly difficult to find that we will have 0.4 grams of fat in a cup of milk plus 2 grams of fat in 1 ounce of meat and 2.3 grams in a slice of bread. And it's up to you to limit it. Say we want it to be less than 10 in a day. The same can be done with other nutrients, proteins, and carbs. But here what we can see the variables. What we have to say is that they can be 0, but they cannot be negative, right? It doesn't make sense to have -1 cup of milk a day. So we should say is that x1, x2, and x3 should be non-negative. Easy. Okay, so what do we have left? We have the cost. Again, it's not a big deal to find out that it's something like 50 cents for a cup of milk. It will be something like 80 cents for an ounce of meat, and something like 30 cents for a slice of bread. We cannot limit it because we want it to be minimal. And we will leave to the program to find that minimal cost. So we'll just leave it like this and leave it as a function. So this is a mathematical program. This is the structure that you will find every time if you're looking at a mathematical program. It has a function, which is an objective, which is the function that is excuse me, optimized, which is the function where we find this variables, this values. There will be constraints, and there will be decision variables. When the process of finding the values, in our case, the amounts of the products, is optimization, because here we will find the optimal values. So I hope that you found this interesting, and I would like to continue on this and tell you how easy it is to solve this problem that you can do at home. Thank you.